Welcome to the webinar on what's new in Advanced Design 2024. This will be a general review of new main features and improvements to Advanced Design. My name is Mateusz Budziński. I'm a product line manager for structural software in GRAITEC, and I have a pleasure to briefly present you the improvements of this version. This version of Advanced Design is driven by three pillars. New computing capabilities. This includes calculation of carbon emission, estimation of costs, and improvements to the finite element calculations. The second pillar was to increase the efficiency and meet customer expectations. It means changes and new options that improve the user experience, but also different smaller points requested by our customers. And the next pillar is related to increase design capabilities for steel, for timber, and concrete structures. And for this, we have a huge number of novelties and improvements. I will mention four novelties. The first 2 points are related to sustainable design, especially the carbon emission estimations that are becoming more and more important and soon will be mandatory in many countries. And the last two novelties are related to the finite element calculations. So let's go in more details. Advanced Design is now equipped with a new carbon emission calculations to help to evaluate the environmental impact of the choices of construction materials. The main purpose of such calculations is to determine the embodied carbon values for structural elements. Embodied carbon is the carbon dioxide emissions associated with materials and construction processes in the life cycle of a building. This includes the emissions from manufacturing and transport of our building products. So we can say that the embodied carbon emissions is related to the production process and to the construction process, and about 90% of emissions from that part is from the production stage, so from modules A1 to A3 of the building's life cycle. That's why carbon factors and carbon emission for a structure is estimated based mainly on materials used for a structure. Carbon factors are defined by the material type, and even for the same material can be different on each country and even for each producer. That's why on Advanced Design, there are tools to easily create and manage a list of used carbon factors, so we can create our own databases. Carbon factors can be easily assigned to materials or even selected elements. We have there many interesting possibilities on Advanced Design, like defining factors not only by the weight, but also by area or volume. So whatever the source info for carbon factors we use for producers or from government data, you can use this on Advanced Design. What is interesting, we can also easily estimate the influence of reinforcement for concrete elements based on the reinforcement ratios we get after the design calculations. The results of the carbon emission calculations are available in the graphical form and in the form of report tables. Graphically, we can see values per type of the element with using values or colors. And the tabulated results can be presented by material, by element type, and also by systems. So in general, we can easily see the impact of each category of objects on carbon emission, and we can prepare documentation for that. I'm switching to the next novelty, cost estimation mechanism. These new calculations allow quick estimation of costs. The principle is simple. We need to multiply the quantity of each material and modeled elements by defined unit price. The workflow and tools for defining and assigning unit costs are very similar to these used for carbon factors. So we can define data per material or element, and results you can see in the graphical format and also using report tables. The next point is pure enjoy novelty. It's a new calculation method for nonlinear analysis. The sentence you see gives the main message. So we have now the ability to conduct nonlinear calculations using displacement increment steps, which allows to correctly analyze highly nonlinear problems with the post-peak behaviors and the snap-through problems. Yes, it's a difficult sentence. That means that for some projects, having elements where the sign of forces change rapidly, as we can see on the simple example on the left. So instead of using classical force-driven nonlinear analysis, now we can use deflection-driven nonlinear analysis to get correct results. And the second point related to pure finite element calculations, in fact, two big changes that were made to the defining initial constraints. It means initial stresses defined to linear elements. First, now we define initial constraints as loads per load case, so we can consider such in load combinations. And the second, now initial stresses are considered during finite element analysis and not only during the design calculations. It means when defined, we can even deform structures to relieve the initial stresses. As you can see on this example, when bottom bars are stressed, and because of that they are shortened and make that the beam is uplifted. Now we'll check improvements that gives better efficiency of everyday work. This is a summary slide that shows few points I want to present on this part. There are improvements that makes work faster and easier, but also other novelties that were requested and expected by many users. I will present such quickly on the next 5 slides. I start with a set of new options that improve the speed of object selection. Firstly, we implemented a feature that allows save templates for selection. This means that to any graphical selection, we can assign a name and save this selection for a quick access in the future. Second, we introduced quick commands for selecting identical elements. For example, if we need to select all slabs with the same geometry or with the same material as currently selected one, this can be done now just in 1-2 seconds by using new commands. We also added new commands to recall the previous selection. So all such improvements makes that everyday work is faster and easier. The next point is related to faster search of steel profiles from databases. The first change is a possibility for filtering sections by type. For example, to see only C sections or rectangular hollow sections from all databases. We can also filter selections by text. For example, we can start entering the producer name, and the list of available libraries will be automatically narrowed. Again, all that makes that finding steel sections is just faster and easier. In this version of Advanced Design, another set of dialog windows were updated, so giving them a unified appearance. So it's not only to modernize the program by switching to newer component, which is also important, but also improves the perception during the everyday work. In case of some windows, especially the window for element selections by criteria, we changed also the content, so we provide also additional new options there. There are also many smaller improvements that are intended to make Advanced Design better adapted to needs from selected countries. For North America, we added new databases of materials and a database with typical code form sections. For Canada, we improved the generation of seismic load combinations to consider the occurrence of opposite directions of seismic forces. And for Spain and Portugal, we added translations on missing areas, like on the section editor. And there are also improvements that are especially useful when working with bigger projects. First, in case of models where we have thousands of load combinations, the generation time is now much shorter. Second, in case we have multi-story building with column slab system, and to smooth extreme values on slabs above columns, we generate automatically master slab links. Such links are now grouped into a dedicated system, so it's much easier to manage such links. And now it's time for new design capabilities for steel, timber, and concrete structures. Note that for such novelties, there are 3 dedicated separate What's New webinars, more technical, where you find more details. But of course, I will show today a summary. I will start with the steel design. For steel design, the first and the really big novelty is a possibility to perform the verification of cold form steel profiles according to the American standard AISI S100. Calculation covers the structural capacity of the cold form steel sections. We can calculate cold form sections defined as parametrical sections, but also sections taken from the libraries. Now I switch to steel design according to Eurocode. Advanced design can now do a check of webs of ice sections for shear buckling, according to Eurocode 315. This verification can be critical for deep ice sections. As these analyses can consider existing of transversal stiffeners, for this we can now define positions so such stiffeners along a member. The method implemented for calculation is the effective width method. Well, just a comment, for the next update, we'll provide also the reduced stress method. So both Eurocode methods will be available on advanced design. We have more control over design calculations of cold form section according to Eurocode now. In short, we've added additional options and possibilities for buckling and lateral torsional buckling. For buckling, we can define the critical length, and for lateral torsional buckling, we can define intermediate or even continuous restraints along the conformed members. There are also other options, and all that makes that we have more flexibility for designing the cold form section. And the last point related to steel design, on advanced design and the steel connection module, we can define now and verify welded truss tube connections. We can define multiple configurations supported by Eurocode 3 with 1, 2, or 3 diagonals that are made of square or rectangular tubular steel sections. The main beam can be also tube or ice section. New connections can be modeled directly on the steel connection module, but can be also modeled on advanced design and opened for design calculation on the steel connection module. All required design verifications, including weld verifications, of course, are performed according to Eurocode 318, in fact. Now we switch to new timber design capabilities. First, with this release, we can verify, according to Eurocode, timber beams with a double rectangular sections. Such beams are commonly used as collar ties or rafter ties. Such sections can be easily modeled by using new parametric section type. The design is run for such beams in the same manner as for usual rectangular sections, but of course, with adjusted parameters. The next point is also related to Eurocode and spaced sections, but refers to columns. Now we can verify timber columns with 2, 3, or 4 identical rectangular sections. separated and connected by packs or gaskets that are fixed by glue or mechanical fasteners. And this verification checks the axial load capacity on such columns, as well as loads on connectors, considering their type and distance between them, all of course according to EuroCAD 5 rules. The next two novelties refers to new checks related to supports of timber beams. The first one is a new verification of the compression pressure at supports according to EuroCAD 5. Now it can be activated for both ends of timber elements, and similar as for other timber verifications, results are available on the shape sheet and on a related report. And the next new check related to supports on beams. In advanced design, you can do a verification of notched beams at supports according to EuroCAD 5. Notches can be defined on start and end of timber beams on top or bottom side. This verification checks if the shear stress and the notch support does not exceed the shear strength. And the last point related to timber design, as you probably know, for timber elements, you can automatically select the optimal dimensions based on their strength. And now we can find optimal cross sections also based on deflection results. So when the current deflection ratio exceeds the limit, you can find automatically a section for which none of the various deflection components exceeds the limit value. So of course, we can define additional rules like the section size limits and the increments. Of course, now we can use both types of work ratios for the optimization. So from the strength and from the deflections. And now is the time for improvements related to the reinforcement design. The number of novelties is really big, but as there is another dedicated webinar for this topic, I'll show just a few slides with selected novelties. In fact, all novelties are related to design modules like RC beam, column, footing, or slab. And there are some common improvements to all modules. So first point for these common novelties, value for the reinforcement steel ratio is now visible in the info panel immediately after the calculation. So now we can check this quickly for a whole element, or in case beams also separately for each span. And next new point is a possibility to apply a project template on already opened element anytime during the design. So anytime you can apply settings from a template, and not only when starting new elements. Now, 3 quick points related to improvements to RCB module. First, with new version, when a rig beam is exported from advanced design to RCB module, instead of a rectangular beam section, the equivalent T section is imported with integrated design forces also. The second point, now we can define or import from advanced design model beams that are perpendicular to the considered beam. Depending on the size and the function, such beams can play a role of supports or just be secondary beams. And finally, we have better drawings also because not only that perpendicular beams, but also we can see the real position of columns. So if they are located only below or also above the beam. The next slide is for RC code module. First, we can now define or import from advanced design model the geometry of upper beams, which can be used for automatic determination of column backlink length. The next point is for editing bars, and more specifically, we can select several methods for defining the distribution of transversal bars, which make it easier to edit or redefine bar distributions. Time for foundation module. The first point is a small improvement. When we have defined a multi-layer soil and activated the verification using the substitute foundation method, then such a substitute foundation is now presented in the view. The next new option is a possibility to correct the crack width on the footing path by automatically increasing the reinforcement. So when activated, in case the crack width is bigger than the limit, then additional reinforcement is added to decrease the crack width. Time for RC wall module. First, when generating drawings for walls, you can use new drawing styles that allow automatic generation of schedules for bars and fabrics at once. And the next point, for shear walls, it's possible now to import and export resultant forces using an Excel sheet. This is helpful, especially when raw data is available from external sources. And finally, we have RC slab module. I'll start with new bar shapes. You can define anchoring of bars using not only hooks, but also by using U-shaped bars and double bend bars. We can now manage anchorage details separately for each zone and for each direction. And another novelty, a second point, are two new possibilities for generating automatically or manually reinforcement zones. For automatic generation, we can define the minimum reinforcement area for a layer, which makes it easier to control the process of automatic selection of zones. And for manual definition, we can now use two additional methods for graphical defining zones by using 2 points or by using a line. So there are two new methods for faster and easier defining zones. But for RC slab module, we have also many improvements to drawings. I will mention only 3. The first, we can generate views separately for reinforcement directions. So, for example, with bars only for X and only for Y direction, as you see on the screen. The next, openings have better representation thanks to a special shadowing. And finally, we improved bar annotations, starting with better automatic generation, avoiding collision with other elements, to the possibility for changing manually positions of parts of descriptions. For example, bar mark can be moved separately to the dimension lines of the distribution. That's all about novelties. It was short, yes, and it's just one slide at the end. It's about the next edition of the Advanced Design Award. This is a competition for all advanced design users for projects made with using advanced design. Please go to the website for more details. You can find this website from the GRAITEC.com, or even you can Google to find it. There are many benefits and there are nice awards, prizes, so it's really worth to register. That's all. Thank you and have a nice day.